Hello, this is John from caveofprogramming.com. In this tutorial we're going to look at const in C++, which is a very important keyword. Believe me, I'm aware that in this course we've gone through a lot of quite dry concepts, but we are going through kind of the minimal concepts really that we need to do any useful code. And const, although it might not sound very important, because all it does is keep things from changing, basically, it is actually very important, and we can't really progress further without it, so we better look at it here. So let's declare an int here. Let's say int value equals 7, and of course a variable, the whole point of it is that it can vary, so we can change the value to 10 or whatever. And let's just do a cout here on value, why not? And let's just run this. By the way, I've created a little class up here, and I'll go through that in a minute. Don't worry about that for now. Let's run this. So we get 10. Now, if I type const before int, then that means that we've now got a int that is const. In other words, it's no longer a variable. It's actually a constant. It can't change. So this line is not going to compile. Let's just build that and prove it. And that's very, very useful, because sometimes you have got values that don't change and you don't want them to change. And if you've got a value that you don't want to change, you should always declare it const so that it can't be changed, like this. It's also quite common practice to make your constants uppercase. We could say like pi. Let's maybe make this a double, because pi is going to be a double. And 3.1415992, I think that's pi. I always remember it with how I wish I could calculate pi. It's the number of letters in each of those words, but anyway, that's irrelevant. So I put this in uppercase to underscore the fact that it is a constant and not a variable, and that's a very common thing to do. Let's just run that. There we go. Now you can also declare methods, constants. Let's take a look at this animal class that I've created. Maybe the easiest way to explain this is to show you. So I'll create an animal here like this, and I've given it a method called setName, so we can do animal.setName. Let's set it to Freddy. And I've also given it a method called speak, so we can do animal.speak, and that outputs the name. So let's just run this. And it says my name is Freddy. Usually, most often, we'd declare a class in a header file, and we'd put the implementations of the methods of that class in a separate CPP file, a separate source file. But in this case, I put the class here because we can do that, and it's easier to read for this tutorial. And I've put the implementation right here as well. So we've got inline method implementation here, meaning it's declared right where we create the class rather than being in a separate file. And that's useful for very small methods usually in your class. Here I'm just doing it for the convenience of this tutorial. So this method here, setName, changes instance variables of the class, of each object. In other words, it changes the name of the objects. But speak doesn't change anything. And if we've got a method that doesn't change any instance data of the class, in other words, well, strictly speaking, the class can't have instance data. The objects have instance data, but this is like a template for saying that each object is going to have an instance variable called name. So each object will have its own separate name variable. And if you've got a method like this that doesn't change an instance, any instance data, you can declare it const. And that will prevent you from changing the instance variables of the objects here in that method. And I've typed const after the round brackets of that follow the method name and before the implementation. So now this is still going to work. If I run this, it will work just as before. My name is Freddy. But if I did something in here, like I tried to change name to something like that, then that is now not going to work. It's not going to build. Let's build that and we'll see. So we get errors, and if you look at the error, we'll get something like Well, it's a bit cryptic, as C++ errors tend to be, saying no viable overload equals, but it's telling us that there's no form of equals that makes any sense here in this context, because this is a const method. If that wasn't there, we'd be able to do that absolutely fine. So if I can build this, but because we don't want this to be here, we don't want this method to change anything, it's good practice to declare it const. I and many other programmers are a bit slipshod in declaring things const sometimes, especially methods. But if you've got a method that you know doesn't change the instance data, really you should declare it const, just to reduce bugs, to reduce accidentally changing something, which is far easier than you might suspect. So now we can't accidentally change anything in this method. Const can get a little bit tricky, as can type declarations in general in C++. Let's take an example of a kind of typical example of such trickiness. So let's create an int here, int value equals 8. We can declare a pointer to that value by saying int pointer p value, and we can initialize it here if we want already, and say it's equal to the address of value. Then of course we can output that like this. We can say cout thing pointed to by p value, and that will give us 8. So this is dereferencing the pointer, getting the thing that it's pointing at, which is going to be the value 8 ultimately. So we run this and we've got 8 there. Of course, if we change this at this point, then we get something different here, because the pointer is just referring to the memory location of that variable. It's a lot like a reference. So there we've got 9. Let's get rid of that. Now what I want to show you is if we can do two things here to actually change this. Let's do it after that cout. We can change the kind of pointer variable in two ways. One way is, let's say we have another value, let's call it int, I don't know, I'll just call it number, and I'll set it equal to something, just why not really. So int number equals 11. I can say p value equals address of number. Nothing stops me pointing that value, pointing this pointer at a different int. It's fine. Let's output p value again down here. Now it's going to say 11, and we've got 11. And we can also use the pointer to change the thing that the pointer points at. So this is actually changing the pointer itself to point somewhere else, but we can use the pointer to change whatever it points at. We can say thing pointed to by p value equals 12, and we're also allowed to do that. So we can change the, let's not do that. What did I do? Yeah, I've got a capital P by mistake. So we can change two things associated with the pointer. We can change where the pointer points, and we can change the value that the pointer points to. So now here, here where I declare the pointer, I can say const before the int, and we can read this backwards. So this is now a pointer to an int that is constant. So that means that we can't change the int that the pointer points at using this pointer. It's a pointer. This is a pointer to an int that's constant. The int is constant as far as this pointer is concerned, and we can't change it. So that means if we compile this program, we're going to get an error here. Here we're trying to change the int, and the int is constant, so we can't do that. So this gives us an error there. Const int value. Let's maybe copy that. Let's say error with this. What if the const was actually here? Now, if we read it backwards, now we've got a constant pointer to an int, and that means the int isn't constant anymore. the pointer's constant. We've got a constant pointer to an int. So we can't reassign the pointer to point somewhere else. Now we get an error on this line. Let's build this and we'll see. So we'll build this, and now we've got an error here because we can't reassign this pointer. So let's copy this and say error with this. So if I delete that, we're allowed to do both as before. Let's just run this. There we go. And you can use both together. So if we say this and this, now we've got a constant pointer to an int that's constant. So we can't point the pointer somewhere else, and we can't change the int that it points at. We could change it using the original variable, but we can't change it using the pointer, because the pointer, as far as the pointer is concerned, the int is constant. So that's kind of a good trick there. If we build this, we're going to get errors with both of those lines. So let's maybe comment this out, because I like to leave my programs in a working state. And let's get rid of this const and that const, so we can build this. So that's a kind of a neat trick for interpreting const, and interpreting types in general in C++ is to read them backwards, because that gives you a truer reflection of what they mean, and reading them forwards. Const pointer to an int that's constant. Okay, so I'm going to leave it there for this tutorial. And as always, I'd recommend practicing this. Start with declaring your own constants and verify that you can't then change them. Try creating a constant method and verify that you can't change instance variables of your class using that method. And finally, experiment with pointers. Try to declare a pointer to something that's constant, and try to declare a constant pointer. And also try to declare a constant pointer to something that's constant. So try all the possibilities that I've gone through in this tutorial. And again, although you won't feel fluent after doing this, it will help fix that in your mind, so that when you use it later on, you're going to understand it much more readily than if you don't do these exercises. But of course, it's up to you. If you just want to watch these videos and try to write programs, that's probably what I'd do myself, if I'm honest, because I'm so lazy. It's just that they're bound to get very confusing if you don't do any exercises. So I'll leave it there, and until next time, happy coding.